Hello, I'm Jeff Weinfeld. I'm here with Aaron Sadholz, and we are engineers at the University of Rochester taking Professor Polkey's Csc160 course, MATLAB for Engineers. For this extra credit competition, we've used MATLAB to solve a common engineering problem that many mechanical engineers face.
The mechanical engineering problem that we are addressing is verifying whether a truss passes under compression and tension. Here, we have an example of a truss with 250 kilonewton loads applied to it. We also have the readings for the tension and compression values within each of the beams, along with the length of the beams, the cross-sectional area of the beams, Young's modulus, the beam strength and tension, strength and compression, and the second area moment. All of these factors are important when considering whether the bridge passes or fails. To verify whether it passes in buckling, we examine the critical force. The critical force is equal to pi squared Young's modulus times the second area moment divided by the length squared. If the force transmitted through the beam in compression is greater than this value, it fails. If it's smaller, then it passes. In crushing, the applied stress in the beam is equal to the force in the beam divided by the area. If this is less than the strength in crushing or in compression, then this passes. Similarly, in tension, the same calculation is used, as the applied stress in tension must equal the force in the beam divided by the area, and if this is less than the strength in tension, it passes as well. Here is our script for our program. First, the program asks the user to enter how many beams in the truss need to be verified. It is important to realize that not all beams in the truss need to be verified, because some beams with the same length and force value don't need to be done twice. Here we use A equals 0 as a counter to make sure that we test the correct number of beams. First, we prompt the user for if the beam is in compression or tension. Then, we ask them for a variety of properties if it is in compression, and we plug it through the appropriate equations to determine whether it passes or fails. Then, we do a very similar test for tension if this is the case. Afterwards, it reads whether all beams pass or if the structure fails in the amount of beams that it fails in.
We will now test the beam for the examples shown at the beginning of the presentation. There are 3 beams in the stress that need to be verified. Young's modulus is 1 times 10 to the 8th pascals. Safety factor is 1, and we will test compression for the first beam. The compressive force is 150,000 newtons, and the cross-sectional area is 1 meter squared. The strength under crushing is 5 times 10 to the 8th pascals. The strength under crushing is 5 times 10 to the 6th pascals. The length of the beam is 8 meters. The second area moment is 1/12, and as you can see, it passes under buckling and crushing. For the second beam, we will test tension. The tensile force is 150,000 newtons. The cross-sectional area of the beam is 1 meter squared, and the strength of the beam in tension, the strength of the beam in pascals is 4 times 10 to the 6th. As you can see, it passes. For the third beam, we will also test tensile force, which is entered in as 212,100. The cross-sectional area is once again 1. The strength of the beam in tension is 4 times 10 to the 6th pascals. And as you can see, all beams pass in this situation. We have verified the code for 3 different types of beams. 1 in compression, 2 in tension.